Good morning. Thanks for joining me in this talk around scaling AI on hybrid cloud for production LLM inference at scale. My name is Roberto Carratala. I'm a principal AI architect working in the AI business unit for Red Hat. And today we will start with just one story. And that's one story that we wanted to tell in order to more or less have a background. But I received one morning a call from my boss, and he told me we need to provide a cluster with LLMs, so with these AI models for all Red Hat employees. And I said, all right, fair enough. We can spin up one cluster and everyone can get their own models and their own GPUs, right? It was easy, kinda. But afterwards, we wanted to have these models as a service, so anyone that wanted can provide their own endpoint and provide their own LLM in order to start playing and also doing code, also powering all the AI apps as well. But we found that we have almost 20,000 employees. So if anyone and everyone grabs a GPU, I will got fired, and I don't want to be fired. So that was the first challenge that we noticed. We should scale and also be cost effective. So we couldn't give every single Red Hat employee a GPU because it was not scaling properly. And obviously we had not that hardware. GPUs are very expensive, very hungry power, and you need to be able to scale and be cost effective. Also, another challenge is that we had GPUs, but they are small ones, and we wanted to save the cost because this was not running productive outside of Red Hat, so we wanted to keep it short and sweet, but also give the possibility to the different Red Hatters and the different colleagues in order to grab this and use it. So the thing is that we have GPUs, but they are smalls. And they have 24 or 38 gigs of VRAM per GPU. So that's not very much if you compare with these larger ones. But still, we can do certain things there. So I'm in this situation. I don't know what to do. I'm a little bit, let's see what's going on. So let me start our journey to scale in production, and we will teach you a couple of things around what are the techniques, what are the solutions, and also what are the different community projects that you can use in order to have this. So how many of you heard about llama? Llama is very simple, right? And you can just with one click and one terminal do all of this. So you can do llama and that's all, but this is running again in your laptop. What happens when there are too many people request? Like you start with a couple of folks around that, but afterwards it's growing fast and fast and fast and fast, and you have a lot of people there trying to request to your model. Well, we end again into this situation that we cannot scale. So one model running in my laptop or one model running in llama, the problem was that it was not very performant. So this is the chart that we use. If you see down, we have the number of concurrent requests. So with llama, we have always the exact same bandwidth, so we cannot scale as we wanted. So we used also vLLM. How many of you heard about vLLM before? All right, vLLM is right now the standard for running LLMs in production. And because it's very optimized, and we will see, it's designed to run in production. So that was specifically the chart that we can see, and we should scale, be fast and cost effective as well, because we want to be able to scale at certain point in order to have a lot of concurrent requests, because we want to put this as a models as a service. So it's sharing one model across every single employee that we had in Red Hat. So this is also another chart. The number of requests, if you see here, is growing up. So this is highest beta, for example. and this is the throughput versus concurrency. This is the number of concurrent requests. So this is the way that Ollama could not scale, and vLLM was also scaling as much as concurrent requests and also throughput. So the challenge with this is that the LLM inference, and there is a lot of wording, but essentially is that when you are dealing with traditional inference, struggles for production workloads because you have these models that are very, very large and requires also high concurrency. And you need to have things like high latency, increasing the idle GPU time, and also do different things around the different replicas of the LLMs. So essentially, what's unique about vLLM? vLLM is a community project that was also open source from day zero. Neuronmatic, a company that Red Hat bought a couple of years ago, and now it's the engine of our Red Hat AI products. So everything that we are running with vLLM in order to power the different AI models. And the reason why vLLM is brilliant is that with current LLMs, you have several inefficiencies. For example, you have bottlenecks by token. When you are trying to generate the next word, you have different bottlenecks. And also, we have other things like fragmentation, batching, and this is reducing a little bit the agility around this. vLLM includes 4 different things. Just focus on the names that is speculative decoding, continuous batching, and page attention. So essentially, it's trying to address different things that we will see just in a minute. So we are trying to deploy the LLM, but also make it faster and optimize all of the concurrent queries. So let's focus on the different things. But one thing that is important, and a lot of our customers, partners, and everyone is asking is why vLLM is so good for running everywhere. It's because you can run vLLM on any hardware and also on any platform. And that's brilliant because it supports almost the largest families of the AI models. I don't want to say all of them because this is recorded, but all of these models and more. So the things that we are doing, it's working, the vLLM engineers and also the community, it's working with, I don't know, Google, Microsoft, NVIDIA, the Qwen family, Llama, DeepSeek, in order to, once they release, even before, they have the day zero. So we also support, and you can run vLLM with the largest models. If you go to Hugging Face, that is the GitHub for the different models, you can run this. And the good thing as well is that you can run all of these with other type of accelerators. Obviously, everyone knows NVIDIA because it's right now one of the largest ones that produces also GPUs or accelerators. But we have also AMD, Google with the TPUs, AWS with Neuron, Intel with Gaudi, and others running on CPU. And that's important because for certain use cases, you don't need to have a GPU. You can run it also on a CPU. Obviously, the performance will not be the same, but for certain use cases, especially with this ARM or AMD or Intel, you can run certain models, short ones and small ones, very optimizing the Intel ones. So a couple of techniques, and vLLM is usually mainly focused around 2 core concepts. The first is inference optimization. We want to make the models faster. That's the first thing that we want. And also, it's usually these models requires a lot of GPU. Imagine GPT, imagine other models or the DeepSeek ones. The largest DeepSeek model, for example, cannot fit in 1 GPU at all. So you need to be able to deploy all of these across different GPUs. It's like with the clusters that we have, the exact same thing. It's trying to distribute the model, chunk the model across the different GPUs. So vLLM is enabling that out of the box with just one single line. And that's all. One flag, and this will be resolved. So let's start with inference optimization. First of all, KV cache. In a simple terms, it's trying to, when you are trying to speak with an LLM, you need to just transform everything that you are saying into tokens. And when you have this type of conversations, like you and me, we are doing, you need to recompute all of these tokens again and again, and again. So we are doing a technique that it's not new, but it's very good, that it's using cache. Instead of generating again and again and again and again, we are catching all of the tokens that has been already generated. And we are using it in order to, hey, if we are recomputing all of the tokens again, we can be faster because we can save a lot of money and a lot of time. On the other way around, we have the batching, and it's a way of trying to put the different and optimize the different batching. Instead of waiting, we can add more, and we can try to fit all of this instead of just waiting for the next token. So we are making and we are optimizing as well this. What this produce? That once you are trying to produce the next token, with this will be very, very, very fast, and you are trying to optimize. So this is an original innovation that Ollama has not, and others has not, because this is meant to be for production. And that's the most important part, that you want to have all of this running in production and hitting again, I don't know, if 20,000. And we will put some numbers afterwards, and you will see how it looks like under the hood. Other thing that is important, why optimize our models? I mean, you can run, obviously, the largest model out there, right? Well, if you are not optimizing your model, you will have and you will spend a lot of VRAM, that is the RAM for the GPUs or the accelerators. And the thing that we want is to be able to have all of these models. And the thing that we are doing, and you will see, is that we are validating and also quantize all of the models. So we are compressing the models, and we are also validating that that's running. The things that we are doing is like offering this set of reduced of the different model size in order to provide this. And if you scan this QR code, you will land in something that is similar to these models. And you can select, for example, the different models. Just give me a sec, and you will see this is just a couple of models that we have, but we have a bunch of different ones that you can run if the Wi-Fi allows me. But until there, as you can see, we have a bunch of different ones that you can select, and like the new one, Quen, that we fully optimize. And you have also performance insights in order to see what's going on. So we have available all of this catalog in order to grab the one that you want. And if we put all of this together, as you can see, the left one is Ollama, the right one is vLLM, and it's very, very fast. Why? Because we are applying out of the box certain cases, like we are using quantized models, so short models. Also, we are using things like spectre coding and pre-fill caching, but essentially it's trying to optimize, so using cache and using other techniques in order to be faster, and also try to distribute the load across the different workloads. So that's important. Then we have our model optimized. Check. Fair enough. We grab the largest model, DeepSeek, the Quen one, the 325, or the Llama one. They cannot fit in just one GPU at all. If you grab the non-quantized one, you can see, and you will see that this is not obviously possible to run. So you are starting with this single device, single GPU. Then you will move to the next following. What is single host, multi-device? What's this? Usually, the thing that we are trying is to start with one GPU. If does not work, you add more GPUs into one node. And then if it's not working, or if it's not have enough capacity to run it, you will distribute it across different nodes and different GPUs. But this has a cost as well, and we will explain it just in a little bit. Why we need distributed inference? Because, again, models are larger than a single GPU and a TPU memory. You cannot fit this, that is gigantic, 671 billion parameters, in just one GPU. You need at least 16 or 17 GPUs that are the largest ones. And again, in our cluster, we hadn't that type of hardware. We had the tiny ones. So another thing that we wanted to aggregate, like we did when you are doing the traditional visualization, you wanted to aggregate this, and we have different techniques that it's adding parallelism, essentially trying to run the model across different GPUs and across different nodes. This is parallelism, and it's trying to add and efficiently distribute the model across all of the nodes that you have or all of the GPUs that you have. This, without vLLM, it's very, very hard to do because you need to manage everything underneath. But with vLLM, it's just one command, and that's all. So again, the challenge that we had is that we have, and now my clicker is not working, we have GPUs, but not so big ones. So the things that we are doing, it's essentially grabbing a model. This is the layers of the model. Remember, LLMs are models that have different layers, and we are chunking this and splitting across different GPUs. So if you see here, we are passing from one GPU to several GPUs, right? So vLLM supports one thing that is called tensor parallelism, and we applied, and essentially it's sharding the model across different GPUs. And that's not new. That's not something that we invented, the concept of sharding, because obviously databases had this sharding across the time. And also we did some optimizations in order to run, because one thing when you are splitting and you add a request is that all of this needs to be compiled afterwards. So you distribute all of the logic, and then you need to have a response back. That's the problem that we have. And with vLLM, it's just one line, and that's all. So what's the current status of our production environment? We have all of these models running. And these models are shared across the 20,000 people. So that's one thing that we wanted to do as well, is if you could compare quantized versus non-quantized, this is one of the biggest models, also is a model of experts, all right? And this is trying to share, and with vLLM, you have this tensor parallelism that if you don't have it, you need to spend a lot of money, like 640 gigs of RAM, and this is providing me less GPU consumption. So again, if we see the different things, and if we see, for example, if we go to the different validated models in Red Hat AI, we will see the different options, and all of these are validated by Red Hat. So we are grabbing the best of the breed, like Mistral Small or others, and see the different ones. So you can select also like the family or the things that you want. Like if we go to Microsoft, we will have the newest ones, the FIFO, For example, we are also using Gemma ones. And let's go to the meta, and we will see like Llama ones. I wanted to show you one difference that we have. So this is the model car, like it's defining other things, but essentially the thing that we are doing, it's giving you the exact same precision. And as you can see, we are using these models, and we are giving a lot of performance as well across the different things. So you can select whatever model you want and try to deploy it and offer it using models as a service. So again, the comparison is like we, with vLLM and tensor parallelism, we're consuming 75% less GPU consumption. This is a lot of money. If you put, this is a lot of money, because the thing that we are trying to do is compress the models and try to run it in the less GPU memory as possible. Because we wanted to maintain this, but without making dumber, without making it like having less performance. With this, the thing is that, all right, what's the current status? Right now, across the 20,000 people in Red Hat, we served 400 million tokens. And that's a lot. Because, again, this is one model that it's only using 4 GPUs and the small ones. So we powered all of these, having, for example, more than 350 million tokens. And also, if you see the different completion tokens, but the total tokens are huge. In fact, this is just the last month. And we served 150 because we released a model. And this is one model that is the latest Qwens that are running also on 4 GPUs. So with this, instead of spinning up again and again and again one GPU, the thing that we can do is to have all of this shared among a lot of every single employee in Red Hat, and our customers are doing the exact same thing. So let me just share this, and the thing that we are doing is that we already have our model selected. So again, you can go to the catalog. We have a catalog of different Red Hat validated models. So if you click, for example, you will see the Red Hat AI in Hugging Face. We have an organization. Hugging Face is the GitHub for the different models. And we have our different collections. And if you see here, we have a bunch of different families. In fact, the largest ones that we validated, so we have batches. So in March, we validated some of them, and also we validate and quantize. And some of them are really good, like Qwen 3 Coder, for example, has been released 9 months ago, already have 15,000 downloads. And this is also maintaining. The good thing is that it's reducing the disk size and GPU memory requirements by 70% or 75%. And this is super good because if you see all of the evaluations, it's maintaining the ratio. So that's also a way of selecting the different models that we want. All right, so now that we have the models, the thing that we are doing is allowing to the different customers to have some sort of the exact same look and feel as, if the Wi-Fi allows me, as we have in GPT, for example, have different tiers. So you have different subscriptions, and your subscription is allowing you to access different models. So in here, we have this subscription that it's allowing certain people, certain groups, to access certain type of models. So you have different models in here. I deployed one model, but you can have different subscriptions. And in fact, when you define the different subscriptions, you need to select the different models that we have. So I deployed Red Hat Mini Mistral, the NVIDIA Nematron 3, and also the OpenAI GPT-20B. So I can select and I can add the model, add the model, add the model, and then once I added the model, I can also select the token limit because I want to control. I have a friend of mine that by mistake was also smashing my model and took the model down because was also having, without control, endpoints hitting to the endpoint. And I needed to add the token limit. I really like my, my friend, and I didn't want it to be mean, but without token limits, you cannot define that. So you can define how many tokens per second and within the hour, minute, or second. So you can do rate limiting specifically. Once I have this, so once I have, for example, this, I have two tiers, the free tier and the premium tier. So this is only allowing me to produce 100 tokens for all of the authenticated users, and I have this premium tier. I can generate API keys. With these API keys, for example, I can define and I can set up the number of API keys, the subscription that I'm doing. For example, free tier. I will put Devox UK in here. I will generate this one model and the expiration date. I wanted to put it 30 days, but you can have custom. So I will do 1 day, for example. I will generate one API key, and you will see this API key. This API key that have expiration of 1 day, so don't try anything with this because will expire. We will have this, so we can start playing around and interacting straight away. All right, so now that we have this, we wanted to go to the playground and try them out, right? So the thing that I'm doing, and I have this, right, I have this, yeah. And if I just add the feature flags, let me give it to you. I will add a couple of things that I need because I wanted to show you a bunch of different things and the new. All right. And all right, so I have this playground, and then I can just select mine, and I can say, hey. And this will also show the metrics. If I still hitting hello from Devox, and I have my free tier, this will be rate limited, and if you see, it's not responding anything because it's already rate limited. So I'm hitting the rate limiting because I put the 100 tokens, but if I select other, like premium tier, and I do the exact same thing, right? This will land because I have different tiers. So you can also set this to the different developers in order to, hey, I can, for example, define you different tiers and have one tier for the different developers to consume certain models, but not all of them. And that's really, really, really good because then you can have different subscriptions, different tiers, and access to the different models. So I'm obviously more admin in here, but for the different developers, you can set up one model or another model and then do the rate limiting as well. You have also the prompts, you can add knowledge and MCPs, but that's not the reason of this talk. And also you can compare different chat. So if I see this, I can compare, for example, one model and the other model. So if I say hello from Devox, this will produce, for example, all right, different responses. So you can see the different metrics and the TTFT. Let me just make it a little bit bigger. And this is the time for first token. As you can see, this one took a little bit more, but the responses are, for example, different. This is just using hello, how can I help you? And this is the Quen 3.6 that I'm running in another cluster that is hello, great to hear you that you are in. There was always a fantastic event for developers and tech enthusiasts. So that's brilliant. And we can, again, have the different free tiers and premium tiers as well. We can put the temperature and other type of things. But again, we have the ability to share all of this. And right now, currently, we have 2 models, but you can see the different models that we have in the catalog. So if I go to the deployment, and surprisingly, Wi-Fi, it's respecting me, so that's good. Because before I tried and it was not very good, but still, when it's loading this, because it needs to crunch all of the projects, and this is a cluster that we have in in here. So as you can see, some of them, right, are not running only on GPUs. We are also running some of them on CPUs, and this is the keyword. We have quantize. So we are using some of them that are running on CPU as well for certain cases. Obviously, GPU versus CPU, GPU will always be faster. But the cost of the GPU, and especially if you are running all of this, you can run certain models on CPU as well. And that's fantastic because it's unlocking a lot of different use cases. And we have DeepSeek running in here, Llama, Granite, this one that we are just hitting, and also the status around ready or not. Last but not least, we need to know exactly what's going on. Right now, I only deployed one model. We can see memory allocated, CPU utilization, inbound traffic, memory allocated, and so on and so forth. But also, we can identify the different models and how many requests we had, the performance, the replica count. So we are only running one replica, and we will talk a little bit around this. The P90, that is the number of users that had not a very good experience, and also the time to first token. So this is 40 milliseconds, so it's very, very, very good. And the token throughput and other different things. So this is the response time distribution that it's saying that this model is running fast, less than 1 second to provide one answer straight away. So, and also, last but not least, I'm also capable to understand what's the usage. So obviously, this is a pet cluster that I provide, but in production, we have obviously much more. Again, remember the numbers that we put together, that we served a lot of tokens. You see in here that we almost served 400 million tokens in 1 year and a half for this specific model, only for this specific model. And if you compare this on running your own LLM, this is saving a lot of money. Essentially because we are sharing this as you have, for example, and as you go to GPT or to the Claude, for example, and request one API key. That's exactly the same thing. So if I wanted to reproduce this, I can run my model, and this is obviously fully local. I have all of the control for the different models. So I can go to the different AI assets, I can grab the model that I want, and I can request this and generate an API key. And this is an ephemeral API key. The key expires in 1 hour and will not appear into the API keys. Because I can also request this from this endpoint. So I can see this obviously will expire in 1 hour. And I can go to the API keys as a developer and grab from the Devox UK one specific token and create one API key. So once I create an API key, obviously it will appear in here. And again, I'm selecting free tier, Devox UK Premium. And this will not have rate limiting. Generating API key, and then I have my API key in here, and I can start working, or I can start building things, or just going to the playground and trying out very quickly. So, last but not least, what happens and what are the different next steps? So right now, we face a point that we wanted to go from going from one replica to multi-replicas. But what happens and what is happening with the LLM? Because LLM, obviously, when you are trying to work with basic Kubernetes microservice, you can distribute the different loads across the different replicas. So you have your application, you click scale to 3, and this distribution across the different applications will be very fast, and you don't need to think about it. With the static load balancing, you can work. But when you are trying to do this with LLMs, it's a little bit more tricky because you have all of the logic, and the LLM itself is a brain. So you have all of the caches, and you need to distribute a couple of things. So the thing that is happening is that you are basically doing round robin. That it's no matter what all of this information that the LLM contains, I will distribute across the replicas without sense. Then we are not using and reusing the cache. So all of the calculations, we are wasting this. So it's not optimized. And the third one is like all of the requests are routed to the same model regardless of the size or urgency. If you wanted to say, this is important, you cannot say that with traditional load balancing. So what's the solution? llm-d. llm-d is a project that was created by Google, Red Hat, IBM, and others, and NVIDIA as well, that it's designed for the AI stack and is designed for Kubernetes. So it's an open source initiative, it's optimized for Kubernetes, and it's designed to optimize the scale, latency, and flexibility. And how the thing is that you want to distribute the LLM inference across the different nodes in order to do something like this. That's the difference, and that's the main difference. So the thing is that we are using the native capabilities around Kubernetes, Gateway API. How many of you knows Gateway API? All right, bunch of you. So essentially, it's grabbing the Gateway API that is an extension of the route, and then it's trying to do an optimization. So essentially, we are calculating and we are having a KV cache awareness and also other awareness of the optimizations that we have in order to distribute properly the load to the different GPUs. And this also is adding a bunch of different things. So how delivers this? The llm-d transforms the LLM inference into this composable Kubernetes native architecture. And you are trying to making AI as manageable as any microservice you have. So the thing is that is microservice base. We are also doing smart auto-scaling. The thing is that you can auto-scale back, and also you can independently scale different things around prefill, decode, on-cache phases. So we are optimizing and we are scaling, and we are using the more efficient use of the GPUs. And last but not least, models as a service, all of this is using underneath llm-d based on vLLM as well. So we are also having this situation that we have the GPUs. So I'm providing the GPUs, I have my GPUs. I have my models, again. If we go to here, I have my different GPUs. I have the different models that I'm serving. And then once I have this, I can, using the AI gateway, I can provide to the different developers, users, applications, endpoints. Because at the end of the day, our customers, and this is a pattern that every single customer that we are talking is asking, is a way of, hey, I want to provide models as a service. I want to provide this, the private AI possibility of going to my portal, and it's like the exact same way of if you go to Claude, if you go to GPT, if you go to other endpoints, that the only thing that the developer wants is the different models that are available, the different endpoints that I can request, an API key. That's all. The developer don't care around GPUs and all of this. So this is the only thing that we are providing to the developers. Developer environment, the AI gateway, and then the API key. And we, as an admin, we can control rate limiting, tiers, the different models that, because I can allow group A to access to the powerful models or not, and to the production ones, to one specific model that I want to provide information. So in that way, I can scale, because if not, I cannot provide all of the GPUs for every single member of my developer team, because this will not scale. And that is exactly why we are doing in Red Hat right now. We have this Red Hat AI Enterprise, but essentially it's you can run any model in any infrastructure, no matter what. And also you are using llm-d and models as a service in order to increase the different replicas of one model. And we will make this GA next week, actually, because it's currently GA these bits, but models as a service and llm-d will be GA next week. And with that, I guess that, thank you very, very much. And that was me with this conversation. Thanks. Any questions? All right, gentleman over there.
Yeah, thanks. Very informative, very nice talk. What I maybe didn't fully get is how much is llm-d already involved in this GenAI studio that you showed before, your internal or like your platform?
Yeah, I mean, llm-d is providing the inference. And GenAI Studio is just a way of very quickly try things out in order to provide a playground. This is decoupled. So you can run llm-d and put, for example, your open code or your application running directly with llm-d. You don't need the other bit. The GenAI Studio, this one, is only as a playground. So I have these AI assets, and this is just a presentation. You can run only the endpoints and avoid all of this. But this is a nice way, because once you have the model, you want to be able also to try very quickly. Yeah. So this is a way of have a model and also compare between different charts and compare things like the time to first token, or the speed around different things, or the response using this. But could be decoupled. In fact, I'm using this, the different models, but the different models, some of them are not exposed. So I only expose this to models as a service and not consuming in the GenAI Studio, because I wanted to have only the different models that I run and that do. So it's totally decoupled, and you can have the different endpoints in order to consume it.
Okay, one more question. In which part does take care of the whole authorization thing? So when you show the different subscriptions, and so is this part of llm-d then, or is it purely part of what you build on top there?
Yeah, that's a very good question. We are using one project that is Quadrant. This Quadrant is fully open source as well, and this is providing all of the authorization. So this is specifically, it's providing things like the authorization and authentication. So we have the Quadrant that essentially it's a combined gateway API in order to provide this authentication and authorization, and also rate limiting. So this one is the one that is giving all of the power. And if you go to models as a service, these models as a service, a web page that we have, and we will link it, you will see the architecture. So essentially, give me a sec. Essentially, the platform and the architecture, it's here. This is coming from Quadrant. So you have the gateway, and then the auth policies. This is the rate limiting that is provided by Quadrant. So you can run llm-d as the endpoint, and then use Quadrant as the authentication and authorization policy. The good thing is around this is that you don't need to worry about all of this. Yeah. You only need to consume the models and put the rate limiting, and that's the value that obviously we are adding, because the users of Red Hat AI don't need to worry about all of this gradient and so on and so forth. Will be automatic underneath managing, and you will have the different CRs as well, like out policy and the rate limiting. So it's a way of trying to be nice for the people that are not Kubernetes native and have not this understanding of the YAMLs.
Thank you.
My pleasure. Anytime. All right. I thank you very, very much. See you around and enjoy the conference.